quantum mechanical model of atom. It is a theoretical science, deals with the study of motion of microscopic particles like electrons. Okay, it was developed by Schrodinger in 1926. Okay, and this was based on the wave motion associated with the particles, based on wave motion associated with the particle. Okay, now the wave motion of the electron in three-dimensional space around the nucleus is given here. This is three-dimensional space. X, Y, Z coordinates determines the electron is moving in a three-dimensional space around the nucleus, and this denotes the electron wave. Okay, according to this wave motion, he put forward an equation called Schrodinger wave equation. Schrodinger wave equation. Okay, and the equation will be like this: di square psi by di x square plus di square psi by di y square plus di square psi by di z square plus a pi square m by h square into e minus v into psi is equal to 0. Okay, so the electron is moving in a three-dimensional space around the nucleus. So this represents the three coordinates, x, y, z coordinates, and this is a constant value. M is the mass of the electron, h is the Planck's constant, where psi is the amplitude of the wave okay, E is the total energy of electrons, okay, total energy of electron, and V the potential energy, M mass, and H Planck's constant. X, Y, Z are the coordinates. Okay. So in short, we can also write this equation like this: H cap psi equal E psi. H cap is a mathematical operator called as Hamiltonian operator. Hamiltonian operator. Okay. So after solving this equation, we will get the values of E and psi. Okay. Where E represents the quantized value of energy which the electron can have. Okay. E represents the quantized value of energy the electron possesses. Okay, and psi represents the corresponding wave function of this energy level. Okay, corresponding wave function is psi. Okay, so from this solving this equation, we will get these two values. So we can say that the energy levels, energy is quantized. The energy of electrons are quantized, and also it possesses wave-like properties. Okay, which can be represented by psi, the wave function. Next, we are explaining the significance of wave function. Wave function is represented by psi, but this psi has no significance. It is just the amplitude of the wave. Okay. Now, psi square at any point, psi square at any point represents the probability of finding the electron at that point. Represents the probability of finding the electron at that point. Okay, or electron density at that point. So psi square is an important factor here. Okay, which represents the probability of finding the electron, or the probability of finding the electron is proportional to modulus psi square. Is a positive value. Okay. So this is in view of the Heisenberg's uncertainty principle. There also we discussed about the concept of probability. Okay. Now, what is an atomic orbital? Atomic orbital means it's defined as the three-dimensional space around the nucleus within which the probability of finding an electron of particular energy or given energy is maximum. So, atomic orbital is defined as the three-dimensional space around the nucleus where the probability of finding the electron of given energy is maximum. Okay, given energy is maximum. So we can say that this atomic orbitals gives the whole information about the electron located in that particular atom. Okay, and the wave function, this atomic orbital is the wave function psi of electron, is the wave function. Atomic orbital represents the wave function psi of electron in an atom. Okay, and we know an electron contains an electron can have number of wave functions. So also there are many atomic orbitals for an electron. Number of atomic orbitals for an electron, or an electron can have number of atomic orbitals, because atomic orbitals is the wave function psi, and electron can have number of wave functions. So there are number of atomic orbitals for there are many atomic orbitals for an electron in an atom. Okay. Next, what are the main features of quantum mechanical model of atom? First point, electrons in an atom can have only quantized value of energy. Okay, quantized value of energy. Okay, that is, it's represented by E. So electrons in an atom can have only quantized values of energy. Okay, these quantized values of energy and the wave functions, that is E and psi, are obtained from the Schrodinger equation. Okay, quantized values of energy and wave function psi and wave function are obtained from Schrodinger equation. This is second point. Next, third point, psi square represents the probability of finding the electron around the nucleus, and the region around this the probability of finding the electron is called as atomic orbital. So psi square represents the electron density at a point, or probability of finding the electron. Okay. And by finding the psi square, we can predict the presence of the, we can predict the maximum probability of finding the electron around the nucleus, and these are called as atomic orbitals. Okay, this three-dimensional space around the nucleus are called as atomic orbitals. Okay, next point, atomic orbitals gives all the information about the electrons present. Okay, in an atom. Atomic orbital gives all information about the electron. Okay, about the electron in an atom. Fourth point. Next, fifth point, quantized energy levels and corresponding wave functions are characterized by a set of quantum numbers that we will discuss in the next session. Set of quantum numbers. Okay, so this energy, quantized energy and the wave functions are characterized with a set of quantum numbers. They are principal quantum number, then azimuthal quantum number, and magnetic quantum number, spin quantum number, etc. That we will study in the next session. Now the sixth point is, in each orbital electron has definite energy and an orbital cannot contain more than 2 electrons. Okay, an orbital cannot contain more than 2 electrons. Okay, it's important. Okay, all these points we will study next session. Okay, next, in multi-electron atoms, the electrons are filled in various orbitals in the order of increasing energy. That is, in the case of multi-electron atom containing more than one electron. Okay, electrons are filled in various orbitals. Okay, in various orbitals are in the order of increasing energy. Okay, or in the order of increasing energy. These are the main features of quantum mechanical model of atom.